Hi, my name is Christian and I absolutely love modular synthesizers. There, I've said it. And I have loved them for 25 plus years. Since I was a kid, I've always wanted one of those huge, massive modular systems. In my 20s, there's a Swedish group called SAS, Swedish Analog Sympathizers, which have made some fabulous work, and it was a mailing list on that time, and I was part of that mailing list. And they got together to make a modular, and I thought, yes, this is my time. And here is my modular. It is one power supply unit, and it is one VCO. This is how far I got. I got all in. I got the Schaefer panel, everything was really nice, but this is as far as I got. I did get lots of other modules for my modular. For example, I have 3 more VCOs with the same kind that is in my modular, none finished. I have PS3100 resonators. One is almost done and one is not. And I have a whole box full of these unfinished projects. Because somehow I never got, like, a resonator would have been awesome to have. A PS3100 resonator was made by Phonitronic a long time ago as well. 2007, this one, he made these boards. But I needed a system to build all these systems too. And buying a system is really expensive. Like, the most modules in a modular system is $100 plus. And you can buy DIY stuff, and then you come down to $50 for a kit. But still, that is one module, and you need, say 10 modules to have something to actually play with. Don't get me wrong, this is a beautiful VCO, and sitting twiddling the knobs was fun for 10 minutes. And then I couldn't do anything else because I didn't have a VCA, I didn't have an LFO to control these things with. And that is why I'm here today, because I think that there are many out there that either want a modular system or have a modular system, kind of like this one, where you don't have all the parts. And so I want to get up and I want to get a running start. That's why I want to make a modular in a week. So in 1 week we are going to make, if you want to join me in this, I'm going to talk about this more. I am going to make a modular in a week. So the thing is, a week, 7 days, and we will focus on one module each day. This is me after I've been doing this modular, and 4 hours is absolutely the most you will spend on any one module. Actually soldering and stuff like that just takes around, no one takes more than 2 hours. There are a few that takes 2 hours. We will start really easy, and it will become a bit more difficult as we go along. In this episode of this 7 weeks, so this is part 0, the introduction, where I'll go through. So I've made an Excel sheet with all the parts that you need for all the modules that we're going to build. So you decide how many you want to build, and I've written in how many I suggest you do to get a fully functional system. And also we are going to make one module today. Maybe you don't have all the parts. The parts are in the description, but we will make this part anyway. It is the most boring one and the most crucial one, the power supply. We'll make a simple power supply, and it is a very easy project to solder. All the modules in this project will be done on breadboard, strip board, or not breadboard, Vero board or strip board, or three hole pads. I don't know what they're called. And in the end of this week you will have something that looks like one of these modular systems, or one of these if you can't again, if you can't afford the making panels. So I have a friend with a laser cutter, and that's the reason I can do that. This works just as well. They are still divided into modules, and on the inside they are still modules, even though it looks like a mess. But they're still modules. And it's still a fully modular system, although it's just contained in a lunchbox. This is of course a gateway drug. Once you get started you can't stop, at least I can't. And there are already a few modules here that needs to be modular in the second week or something. And this is a modular in a week is by no meaning a full-fledged modular system. It's just to get you going. So then once we've gotten the footwork, the initial thing done, then we can start either building more modules or buy kits and other modules and just be ready. So this system is supposed to be cheap to build, kind of easy as it can get. Some modules do tend to get a bit difficult. We will make it on a Vero board, as I've said before. That takes a lot of thinking how to route the signal, but it's very good. It's to learn where everything goes, and as I said, it will take a few hours each day to get the modules done. It is not going to be a perfect sounding, pitch perfect VCOs and flawless VCAs and fancy pantsy modular system. It will have flaws. Of course, it's a modular system done in a week. So there's that. Also, I am doing this without an oscilloscope. I have ordered one that is quite cheap. I'll put a link in the description for that, or whatever. Once I get it, I'll go through and see it. So some of the modules need a bit of fine-tuning. I can't do that. I will show you how to just tune it so it will work, and then we'll do the fine-tuning once we have the an oscilloscope, I guess. Other than that, I hope you want to join me in making a modular in a week. It is absolutely fantastic fun to hear as you progress and what each module adds to the sound of the second one. It is much fun to see. And also, you have a modular system at the end of the week. In a week, we'll have a modular system. So let's go through the Excel sheet so you understand that, and then let's make the power supply. And I also see on my timer here that I need to say that these episodes, videos, will not be short. They will probably be quite long, but that is because we have lots of information to compress into each one, and again, the work you will have to put in is maximum 4 hours a day. So now let's go into the spreadsheet. The Excel file is built up like this. First off, which module each module is in a column, and the module name is there. If there's a companion YouTube video, it's on this row, link to panel SVG file if you want that, URAC format. It's on this row, link to information online where I found the information, and if there are more links, it's on this row. So, for example, the PSU you can find on syndiy.com in the MadMouse schematics, which we'll go through in a bit. And of course this video will be on the companion YouTube video right here. So there's some notes and how many and why, which is all just more notes really that I want to share. Here is the final, on this row is the final cost for each module, how much each module will cost you, and then I have written in here how many I think you should build, and you can just change this number to any number you want, how many you want, and you will get the total cost on the third row here. Part count isn't really, it's just to see, it's kind of an indication of how difficult the project is. So 10 components in the first version of the reverse avalanche VCO is very small and very easy therefore. And then all the components come here down the line, and how many for each module you can see along here. And then you get the total number. I can't do that. You get the total number in this column. So for example, for the modules I've put in so far, we need to buy 14 jacks. And this is because instead of buying components for each and every one, it is much cheaper to buy them in bulk. And it can even be as strange as buying 100 is cheaper than buying, let's say, 80 of something, because the prices drop very rapidly at 100 usually, and similar things. 1,000 it is for resistors. You can buy a 1,000 pack of resistors cheaper than 200 of them, for example. I want to be really clear that the price for the modules that I've written here, so the component prices I've written here, they are really overpriced, just so it really shouldn't cost, a module shouldn't cost more than the price says in this, on this row. But it excludes the panel if you choose to make that. If you choose to make it in a lunchbox, it excludes the lunchbox. It excludes the PCB or the Vero board, which I'm using, and whatever kind of board you are using, that is excluded. Cables to just tie parts together, and the knobs. You will see on my build so far that I just use the potentiometers without any knobs. It's a aesthetics thing, and it's not, you will have a fully functional synthesizer even without the knobs. And as I said, component costs are set way high, so this should be absolute max you need to pay. And buying in bulk. Yeah. And here you see power supply first, and the one easiest PCB to solder. And here I write some of the optional things that you can buy. which means that they are not in the components, or they are, I don't know. Sometimes they are, sometimes they aren't. You can decide if you want to switch LED and power socket. And then how many and why? I'd make 2 to be on the safe side. It is good to have 1 when testing modules. Buy extra 7812 and 7912. They fry out if you short circuit anything. Believe me, I have tried and it is like that. So actually my 7812 on one of on my, so I have 2 of these. I made 2 because it is good to have one that is in your modular and one that you have on your workbench to try out the circuit you are working on at the moment. And my 7812 and 7912 are actually in headers, so they are really easy to exchange when I fry them. It has only happened once. I don't fry them on a daily basis. That has only happened once, but when that happened, I realized that me being me, I might as well put headers there, which isn't either included in the price of the components. Headers, I forgot to write headers and pins, not included. Yeah, so let's make our power supply. The power supply I'll be showing you is taken from the MadMouse schematics. MadMouse was a synthesizer, analog synthesizer that was made by Electronic for Music, and me and some friends did a few of those also lots and lots of years ago. So I also populated one board with only the power supply to have a plus and minus 12 volt power supply, so that's why I know it works. It is quite simple. So you do need a 12 volt AC wall wart transformer, and this is very important. It is a 12 volt AC, not the usual DC that you usually have, which is just plus 12 volts and ground. We need AC because we need the minus 12 volts as well. And here's a quick rundown of the components needed. The wall wart 12 volt AC, again very important. You need 2 470 microfarads capacitors. These are electrolytic capacitors, and they need to be at least 35 volts. The same, you need 2 1 microfarad capacitors, also electrolytic, and these need to be 30 volts minimum. So if it says 200 volts, that's fine. This is just the minimum value. If it says 15 volts, it's not okay. If it says 30, it's okay. Minimum value, or else you will blow these, and that smells bad. They need 2 1N4001. Actually, I wrote 4002 because I don't have 4001s. 4002 works as well. If you want the LED to show that it is running, you need a 4K 7 ohm resistor and an LED in your preferred color. You need the 7812 and the 7912. And optional is a switch and a power plug. And again, this is the schematics. This is really bad resolution on this one. I'll see if I can make a better one. One thing I like to do is to draw up on paper a simple circuit like this. I draw up on paper kind of how I want to make it on the Vero board. So this is quite linear. You see, here's following this line you get plus 12 volts, and except for the ladder step effect here, you follow this and you get minus 12 volts and also ground. So what I did is I did these
And then I put a lot of headers in 3 groups, one for plus, one for ground, and one for minus. And then I just use headers and DuPont cables to distribute the electricity to the different modules. I did this twice because I did 2 of these, and I would also suggest that you make 2 of these because it's always good to have one out on the workbench when you're working with your one modular or one module and the other one in your modular system. So 2 is good to have, and also when you build out the system and you need more power, it's good to have 2. Depending on your speed, I would say this should take around 30 minutes to an hour to solder one of these together. Take your time. This is not a difficult build, but it's a very important one, and also if this one isn't correct, then many of your modules later on could break because of this one. So make sure that when you're done you measure the voltage between plus volts and ground and make sure that is plus 12 volts. You need to check so you have from the 3 pads of power, so we put it on voltage, DC voltage and 20 volts, so from plus to the red on plus and the black on ground, you should have around 12 volts. And if you take still ground to black and red to minus 12 volts, so this is the gray one here, we should have minus 12 volts around, and we do. And just to really be on the sure side, we can go up to 200 on this one, and we measure red wire on the voltmeter to plus and black to minus, and there we should have 24 volts. So then we know this power supply is okay to use in our modular. Also very important, the pin out on the LM7812 and the 7912 isn't the same. So this isn't a pin out, which I've done here. Very important. I did break once, I didn't break it, but it got very hot, 17912, because I wired that up in the same configuration as the 7812. So here is how it is on the 7812. You have input voltage on pin 1, ground on pin 2, and output on pin 3. On the 7912 you have ground on pin 1, input on pin 2, and output on pin 3. And the reason is I'm guessing that this, so you can put the 78 like this, and the 79 like so, and that way you get ground in the middle, plus ground, and minus down here. So that way you don't have to cross any lines and still get plus, ground, and minus in this configuration. A few thoughts on the enclosure as well. I started out in a lunchbox like this. I still kept to the Eurorack format, so I drew on this the Eurorack format of 128 millimeters width or height, and the width are in HP, so 2 HP is about 1 centimeter. I'll put a link in the description to a really good file or page that Doepfer has that explains the Eurorack format really well if you feel that you want to make your own cabinet. But the lunchbox works well, and again inside each module was its own circuit board, of course. I then moved on, or expanded from this one to incorporate 2 boxes. So this is a cookie box, and here I took the files that I had done in Inkscape and just put a few of them together and printed out. So these are the actual design of the front panels made in Inkscape, which later on then became the modules, like this. This is used a lot in the telecommunications industry, and is actually thrown away quite often. So this is also something I found in the trash or in a recycling station. Again, maybe not something that you want to go around doing, looking for these kind of things, but people are throwing away these, so they're not impossible to find second hand at flea markets and stuff like that. And you can also just with plywood, you could just make a frame and just use, instead of having a panel like this with screws, you can just use wood screws in a plywood to connect them. Perfectly fine that as well. So there are many ways to build a modular, the panel side of things as well. So I hope you find something that matches you and your budget. There's one more thing I need to explain. Patch cables is another one of those that can really, one of those expenses that can accelerate really quickly. I had around 10 of these. You can buy a 6-pack of these. I found 30 centimeters and 60 centimeters is the 2 normal ones, around $10. They're nice. They are mono cables, and the $10 for a 6-pack is the cheapest ones. Then you can buy branded ones like Moog and stuff like that, and it becomes really expensive. But for our intent and purposes, this is enough. But during my 60 centimeters, I got a problem, because when patching in this one, 60 centimeters isn't enough to go all the way. So I started looking around in my drawers and found these stereo plugs that you get with all your, as soon as you buy a couple of computer speakers, you get a pair of these. So probably you have quite a lot of these hang around in your drawers. And these work perfectly for our purposes, because you only use the tip and the ground base of the contact. So the middle ring isn't used in this. And I took this one step further and went online and found a lot of these cables that cost $1 and less. And what I've done, I actually found on AliExpress, I found these 100-pack of nylon woven cables, that 100-pack for $45. So that gives me way down under half the price for these other cables. And that's the route I'm going. I haven't gotten them yet, but I have ordered them, so I'll put the link in the description for this as well, if you feel that you want lots of cables for patching. And with all that said, we finished this video. Put a thumbs up if you liked it, subscribe, and the bell thingy so you don't miss the other episodes where we make this modular. And if you feel like it, please support me on Patreon, where I will, when I have 10 Patreons, I'm going to have a giveaway for the first VCO that I made for this system, the reverse avalanche VCO, which you'll know all about in next week's first episode. Take care, bye.